Our hereditary information is encoded in DNA molecules. Our bodies are made up of molecules of sugars, fats, and proteins. All of this is soluble in water. Why did evolution choose these carbon-based compounds and water? Could life at its origin or on other planets be based on a different principle? We will try to answer these and similar questions in today's episode of the series Secrets of Genes, in which I welcome you. Today's episode will be shorter than the others and serves as a kind of, hopefully interesting, detour on the journey of genome evolution that we are following in our series. My name is Edward Kejnowski, and I work as a geneticist at the Institute of Biophysics of the Czech Academy of Sciences. Today's forms of life are based on molecules of nucleic acids and proteins. But it hasn't always had to be this way. Interesting, though rather marginal, are the views suggesting that the first life could have been based on a different principle. Most often, clays and silicate substances are mentioned. This idea was introduced in the early 1980s by Graham Cairn Smith. Clays are capable of forming crystals, and we know that crystals can grow. Growth is made possible by the fact that the basic units of crystals can create their own copies, that is, they can replicate. However, the growth of a crystal is not without errors. We could call them mutations, similar to the mutations we know from DNA. Clay crystals, says Cairn Smith, can then spread across the landscape, for example by wind or water, with different mutants being more or less successful at colonizing new environments. They accumulate additional layers, dry out or break into smaller particles, and in this way infect other locations. It's a kind of analog to natural selection. There is considerable speculation that primordial clay-based life may have actually preceded and laid the foundation for the prevalent organic carbon-based forms of life. Everything seems quite logical. However, there is a problem. It is almost impossible to imagine a transition from a system of storing genetic information in inorganic substances like clay to genetic systems based on nucleic acids. That is precisely why the aforementioned theory or hypothesis is widely considered to be rather marginal. All known life forms to us are fundamentally based on complex compounds containing carbon, specifically on intricate hydrocarbons, and universally utilizes water as an essential and primary solvent. However, some scientists speculate about the possibility that life elsewhere in the universe could be based on a different element and different solvents. The most commonly considered alternative is silicon. For example, silicon is very thermally stable, which could give silicon-based organisms the ability to live at high temperatures, at which life may have first arisen on Earth or elsewhere. Moreover, silicon is a common element in the universe. In the periodic table, it is located directly below carbon and therefore has very similar chemical properties. For example, like carbon, it bonds with 4 hydrogens to form silane, SiH4, and it forms long polymers called silicones, in which silicon alternates with oxygen, much like carbon alternates with oxygen to create polyacetals. One of the advantages of water as a solvent is, among other things, the wide range of temperatures at which it remains in a liquid state. Another advantage is the large number of substances that dissolve in water. However, there are also other substances with similar properties. Most often in this context, ammonia is mentioned. Most organic substances dissolve in it, just like in water, and in addition, some metals as well. At normal atmospheric pressure, ammonia is liquid at temperatures from -78 to -33 degrees Celsius. However, if the pressure increases, for example to 60 atmospheres, ammonia melts at -77 and boils only at 98 degrees. Measurements from the Huygens space probe suggested that beneath the surface of Saturn's moon Titan there are oceans of ammonia. So on Titan, there could be substances resembling Earth's prebiotic soup. Well, that's all for today. I hope today's little detour was interesting or useful for you. In the next episode, we'll talk about how the first genomes formed and how the transition from RNA to DNA genomes occurred. I'm looking forward to seeing you. If you enjoy my storytelling, I'd appreciate a like. And if you'd like me to continue making episodes about genetics and evolution, please subscribe. It helps these videos reach more people. I really appreciate your support. Thank you, and bye-bye.